Welcome back, ladies and gentlemen. We're going to continue with the videos showing how to convert some graphs by taking the next one in your booklet. I believe this is number 42 for your booklet. So I'm going to show you step by step how I would do this, and that's about it. And then when we're finished, we're going to, of course, make a corresponding velocity graph. So first step, cut up the graph. We cut up the graph when we cross the axis, change shape, change slope. Now, as I mentioned last time, we don't really need to do this for cutting it when it crosses the axis for slope graphs. For area graphs, we definitely do, but not for slope ones. But, for the ease of practice, I'm going to keep doing it, even though it's not strictly necessary. So there's all my cuts. So we get 1, 2, 3, 4, 5, 6, 7. And we're going to have to calculate some slopes, because that is, once we finish the cuts, then we do some calculations. So let's see what we get here. We're looking at, for example, for 1, we're going to get 3 minus 0 over 0 minus negative 10. So we're looking at 10 divided by 3, 3.33. Yeah, we'll just leave it. And it's positive. It's positive even though I started below the axis. Just because I start below doesn't mean that the slope is negative, right? The slope here is clearly positive. Now, when we do the second calculation there for number 2, it's actually going to be pretty much exactly the same number because of how this whole thing is supposed to be working. So let's see. Or at least it should be, but we're going to get just slightly different, unfortunately. So it's 5 minus 3 divided by 5 minus 0, so we're getting about 2.5. Now again, this should be all one continuous line, but because I've broken it up in this particular manner, and because of the fact that I kind of rounded a little bit, if you look closely in the graph, it's not actually at 3 where it crosses the axis, it's a little bit beforehand. So the combination of those two factors has given me different numbers, even though realistically I probably shouldn't get that. But that's okay. For our approximation, this is going to work fine. Here, the slope is going to be 0 because it's a flat section. For 4, we're looking at, let's see, 10 minus 9 all over 0 minus 5, positive 5. So it's just going to be negative 5 meters per second. 5, we're looking at negative 34 for our final, minus 0 all over about 5, so 15 to 10. So it's going to be 34 divided by 5, and that's going to give us 6.8 negative meters per second. 6 is, of course, going to be 0, and then the last one, 7, we're going to get, let's see, it's 20, 16, so we're at 4 on the bottom, and we're looking at, oh, I forgot to figure out what number that is. It's at about 16. So this one here should be at about negative 16. So we're going to be getting a final position of negative 16 minus negative 34. 2 minuses are going to cancel out. And we're going to get about positive 4.5 meters per second, because again, positive slope. Okay, so there are our numbers, and obviously in the red marker here at the bottom of the board is taking up an awful lot of space. I could reframe this into the form of a table or something, but actually I think we're going to have enough room for our graph, so I'm going to leave it. Although if you want to write it in a table, I strongly recommend it. It's very convenient, it keeps things organized. The next step is that we need to know the shapes, right? So each one of these sections has a shape that corresponds. For example, this is a sloped line. A sloped line, we might recall, it goes curve, slope, flat, axis. So a sloped line becomes a flat line. In this case, it'll be a positive flat line. So will this one. This one here will, of course, be a 0 because it's 0, so it'll be on the axis. Because it is a flat line, so a flat line becomes a 0 line. This one down here will be a negative flat line. This one over here will be a negative flat line. This one here will be another zero line. And this one will be a positive flat line. So they're all flat lines, which fits because we don't have any curves here. So there's no reason why we should expect to see curves, or slopes for that matter. So there we go. We have all of the symbols we need. Now we just need to graph the new one. Now I saw a few people when they were making their graphs in class struggle to figure out what axes to use. Put another way, how big to make their graph. So for example, this one went from 5 to negative 34. So a lot of students ended up doing exactly that, 5 to negative 34. The problem with that is the numbers we're going to be dealing with are the red ones. The biggest number we deal with is negative 7. And the smallest number, I guess the most positive, is plus 4.5. So if you go from 5 to negative 34, you're going to have a huge area, and you're only going to use a tiny piece of it. Generally speaking, remember, when you're dealing with graph conversions, the graph you start with and the graph you end with are going to look very different. Okay, there we go. And we're going to be looking at, let's see, we got 20 seconds overall. Yes, so we'll go, let's see, we're going to need a couple numbers here, but we'll just do it by 5. So 5, 10, 15, 20. And we need to go to a maximum height, I said, of 4.5, so we'll go up 5. So 1, 2, 3, 4, 5. And our biggest number down is going to be negative 7 about. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5. So here's negative 5 again, just to make it easy for us. Okay, our next step, we record the points. Once we get the points down, then we can connect them with the lines. So a couple of these are going to be easy. Like, for example, section 4, sorry, not 4, section 3 is 0. So from 5 to 9, we expect it to be 0. So from about here till about, we'll say there, should be a nice 0 line. Similar, from 15 to 16, we expect to see 0. So we go from there to about there, we'll say, there it is. So those two are, hopefully pretty straightforward. The rest of them, they're going to be slightly harder, but not too hard, right? The next one is 0.33, and that happens over the first 3 seconds. So 3.33 is going to be, say, about here. The next area is 2.5, so it's going to be a little bit lower, maybe here-ish, and that's going to happen up to about the 5 mark, like so. Then we've got negative 5 for section 4. Section 4 was from 9 to 10. So from 9 to 10, we're going to be at negative 5, so that's about here to there. Then next section, section 5, we're going to be at about negative 6.8 or so. So that's going to be from 10 to 15, so it's 6.8, which is, of course, going to be pretty low down there to about there. And then the last one we've got is plus 4.5. So 4.5 is going to be up here, like so. Now I'm putting 2 dots like that because I know they're going to be flat lines. But if you were doing it, you may only put 1 dot to start with and then connect it with the shapes after the fact. Okay, so now that this is all here, now we start to map things out. They're all flat lines. There's no slopes. There's no curves. So this becomes pretty straightforward. You're going to get something that looks kind of like that. And kind of like that. And over here, it's just going to be a nice straight line, another nice straight line, and one last straight line. And you may decide that you want to connect these vertically, like so, with some dotted lines. And that's okay. I mean, you don't have to do that. That's optional. It's just to try and make things a little cleaner. So there we go. That would be a graph conversion for this particular graph, or at least one possible conversion. I would mention that if you didn't split up sections 1 and 2 and 4 and 5, then the little extra jogs that we see on this map, on this graph, wouldn't really come in. So if I use, let's say, the red here, just to highlight the difference, if I didn't separate 4 and 5, I would probably have gotten this brought down to here, and I would have gotten this one brought up to there like so. So these little jogs here these little slight adjustments to the graph, are kind of an artifact, we call it, kind of an unfortunate side effect of the particular method that we used. So if you get the blue line there, that's fine, because that's what you'd get if you followed the very straightforward rules of cutting up a graph that I gave you, which is, of course, change of shape, change of sign, across the axis. But if you didn't do that, instead you just treated the stretch from here to there all as one thing, and from here to there all as one thing, then you wouldn't get these little jog-ins, and instead you just have some more solid straight lines. For our purposes, it doesn't make that big of a difference. It'll work fine either way. The only major issue is if we needed to be really precise. Now, admittedly, we did round already because, as I said, this doesn't really cross quite at 10 and that doesn't really cross quite at 3. If you take a close look at the actual graph, it's a little bit off. Not by much, but enough that the combination of that rounding plus these extra little section breaks are sort of throwing things off. If it wasn't for the rounding, they should get the same basic result. But anyway, there you go. This is roughly what you should expect to see for this graph. And you'll notice there's at least 2 spots where you are not moving, right? There's one there and there's one there. And otherwise, it's all flat lines, no slope lines at all. I'll leave it there, ladies and gentlemen. A pretty quick one, right? The next graph on the list is going to be a curved graph. That one's probably going to take a little bit more time. We'll show that on the next video. So, cheers.